Beginnen wir? Okay. Okay. Okay, welcome to Blockchain, Ethereum, and Business Applications. My name is Matthias. I'm working for BSI Switzerland. I'm one of the project leads of the Eclipse Scout project. And we're going to hear about what we've learned during the last year by exploring the blockchain domain at work. So basically, you probably have heard of Bitcoin or Ethereum, and there are tons of other cryptocurrencies as well. There's a lot of money involved, which means that many individuals see now their point in time to start a startup. So if you add blockchain startup in Google landscape, you get tons of small images. Each one is a logo. Each one is connected to a hope of a particular organization or person to get rich quickly. If you're an organization, then this might not be the good approach. What these guys do, you build an alliance or you join an alliance. So it's similar to IoT, when you realize that something big is happening and you start to be anxious that you miss the train. So there's a lot of that stuff going on right now. And recently, there even popped up something like a crypto valley, which is catering for the blockchain community. And contrary to, it's just called the valley in the blockchain domain, but however, it's not located where you probably would expect it. Instead, it's located in the center of Europe, in the center of Switzerland, close to a really small, sleepy town, Zug, which I grew up, which is kind of funny. And so basically, it's between Zug and Zurich. Now, this small town is getting less sleepy by the year because of all this hype. So, how much money is there? We can compare a number of the top cryptocurrencies, the Bitcoin, Ethereum, and some others. If we look for Bitcoin, this is approaching 100 billion US, the total capitalization of the world, which basically is around the GDP of a country like Croatia. Ethereum is only a third, which is around the GDP of a country of Cyprus. So all of this money is creating a lot of excitement, and this creates a situation where many people start to get into blockchain, but what they actually mean, they're just afraid to miss the money train. So they're really interested when to buy and when to sell and all that stuff, and not so many people are really interested in understanding concepts behind blockchain, which are really necessary if you want to judge if something has merit or not. Being special as a developer, of course, and being at the development conference, we're not going to do this thing, but rather this thing. So let's move towards understanding Bitcoin first. Why Bitcoin? It's just historically, because Bitcoin has been the first implementation of a successful blockchain instance. It was created by a guy or a girl, Satoshi Nakamoto. The question mark is because we don't even know if it was a single person or a group of small persons. So this 100 billion is running on an infrastructure initially created by somebody we don't even know. It became open source software in 2009. So let's assume that we have one of these Bitcoin wallets on a mobile. We go into a coffee, and the coffee happens to accept Bitcoin to pay your coffee. So what you do when you pay for the coffee, you get a QR code. Inside of the QR code, you can scan that with your mobile wallet, and there are metadata encrypted or encoded in the QR code. For example, the address where the money is going to, and the amount of Bitcoins that you're going to pay for that coffee. That coffee would never be so expensive because the example comes out of this book, and Bitcoin has exploded in value, so you probably never pay that much for coffee these days. So for these addresses, what is this actually? It's basically a form of account. So if you have traditional accounts who have funds in the blockchain world, you have addresses. In the case of Bitcoin, it's just an encoded number, and that number is derived from a public-private key pair. So how do I get these addresses? How can I use it and maybe lose it? To get your address, basically to accumulate funds and then spend it, you don't need to ask anybody. You just create your private key pairs and derive the address from that, and you're done. So there's no ID required, no showing up at the local branch. Well, there isn't even a local branch to show up. And to send Bitcoins, once you have some funds under your address and you want to transfer those funds to somebody else, you need your private key. because you need that private key to sign the transaction that it's okay for some funds to move to the target address that you designated it as a recipient. This also implies that it's not good losing private keys, because if you lose the private key, you can look at your account, you can see how much money there is, but there's no way how you can access the fund or transfer to somebody else. Basically, the bitcoins are locked into that account and they become worthless. So, a word or two towards a Bitcoin network. What you have seen, you have a mobile wallet or a desktop wallet, whatever, that is usually connected to a Bitcoin client. The Bitcoin client is responsible to send and sign transactions to the network. It mines new blocks, we'll come to that in a minute. And this is really important, it holds a local copy of the blockchain. So that client that you have is connected in a peer-to-peer fashion to other clients. And this whole thing together around the globe is forming the Bitcoin network. So each of these circles has a local copy of the complete blockchain, which means each transaction from the inception of Bitcoin until today is stored in this whole global peer-to-peer network. So it becomes obvious that you can kill many of these, but even if you manage to do that, you will not manage to shut down the network. Because basically you can recreate the whole network even from a single node, if that's an extreme case, but it's theoretically possible. So these transactions, if you send a transaction, it's a so-called unconfirmed transaction, and that is spread through the network. I hope my LAN connection is okay, so we can actually look at that in real life. So this is a blockchain explorer for the Bitcoin network, and here you see the live unconfirmed transactions from the globe coming in. So that page is connected to a Bitcoin, and from there node, and from there you see all that information. Currently the thing is around 4 transactions per second, which is a bit more than half of the capacity of the global Bitcoin network. So let's move back to the slide. So the coffee transaction, what is it? This is from the same blockchain explorer. You have the address where you're sending the funds from, you have the address where you send it to, there's a coffee price, there's a return money that goes to your own address again, and there's a small thing which is called transaction fee. So you have to pay for the fact that you're actually running the transaction. And really important, there's a link to a transaction block. So if Bob's Coffee is really fairly easygoing, when they see the transaction coming as an unconfirmed transaction, they can say, have your coffee. If they're more cautious, they say, no, I want to see the transaction in the block first. If they're really picky, they say, well, you know, there might be a competing sidechain. I wait until I have a couple of blocks on top of that, and only then I believe that the money is actually mine. This leads to a situation where if you just wait for the first block, usually it's supposed to be inside of the block within 10 minutes, but that can really take hours. Depending on the congestion of the Bitcoin network, even small transactions can take many hours until they're confirmed. So there's a huge backlog, probably. This is not often, but sometimes it is the case that the network is not really flush, if you want. So this transaction is we said in a block. Let's look at what a block is. It has a block number, and it has a number of transactions inside of that block, and there's a block hash. In the block hash, it's just a long number, and the funny thing is there's a ton of initial zeros. We'll come to that in a minute. And really important also, there's a link to the hash of the previous block. Basically, this block with our transaction is linked to the block with other transactions before, and that before and so on, we get to block number 1, which is called the Genesis block. And because of all this construction, the whole technology is called blockchain. So how do we come from a transaction to a block? Basically, this is the mining game. We have seen that you have transactions that are unconfirmed and propagated through the Bitcoin network. The client receives these transactions, such as similar as we have seen in the web page. And if enough transactions are there, the client can start to mine. What does it mean? Basically, the client has a pool where it can pull out unconfirmed transactions, put them in that pool, and say, this is my block candidate. And now I'm going to solve the block candidate's crypto challenge. When the client has solved that challenge first, when it's the first guy that has basically solved the new block, if you want, He gets a block reward, which is basically freshly printed bitcoins, and the client also gets all the transaction fees that belong to the unconfirmed transactions, which is basically incentive for the client to first take the transactions that have high transaction fees, and these get usually processed faster. However, when you get this block, you send it to your peers, but that's not the normal case. The normal case is you actually receive a block from somebody else, and that guy did win all the money, not you. This means that you can throw away whatever you've been doing and you start the race over. At step 3, basically you have to recreate a new one with new transactions, and then you can start the game again. So let's look at this crypto challenge. The trick is that we have seen there's a pointer to the hash of the previous block, which is basically this number here. It's just a dummy implementation. Then there's a section which is just a sentence here, which is the payload. Here would go all the transactions that you decided to put into the next block. And there is a small portion of data that's just random noise. And then the challenge goes as that. You have to compute the hash over the whole string, which gives some number. And you repeat that until you get leading zeros. In that case, if the difficulty of the network is just to have a single leading zero, then you don't need to do so many experiments with randomizing this part. In that case, in this example, the algorithm had to run 29 of these guys. If you increase the difficulty to, let's say, 4 leading zeros, it gets more complicated, and it needs actually to compute 11,500 hashes to have the first instance with 4 leading zeros. In the real Bitcoin network right now, if you do the hashing, you need 18 leading zeros. And forget to compute something like that on a normal machine, even on a GPU. You have to have special purpose hardware to do that. And a single one doesn't really help. You have to assign that to a pool, or you have to have many of them, and only then it really starts to make sense to participate in the game of mining and getting money out of the mining. So, BitCap recap. It's a completely decentral currency, so there's no need for banks. Especially there's no need for a central bank, because the network is printing its own money. It's open source on GitHub. You can also say it's open data, because each client has access to all the transactions, completely open. And it's the first successful implementation of any cryptocurrency or any blockchain instance. It's basically the gold standard since 2009, has never been hacked since 2009. And this year, especially, there are record price levels for this thing. The current challenges are the ongoing scaling debate war. As we have seen before, max capacity of Bitcoin network is 7 transactions per second, which is kind of ridiculous if you compare to Visa. But still, it's working. They're working on it. Eventually, they'll find solutions. And there's also a declining market share. That is not necessarily bad, because why is that? There are successful competitions from Ethereum or forks of Bitcoin and many other else. If you want to learn more resources, you can read the white paper that's online available. You can browse the Bitcoin core client on GitHub. You can a book. This is highly recommended. This is either you can buy it in the shop or you can download for free. And also the book is on GitHub. It's using ASCII Doctor, so you're even open to contribute to the book if you find anything that is missing. Now let's move to Ethereum. This is not only a currency, but it also contains the concept of smart contracts. And this is the focus of what we're going to look at. It was created by a guy called Vitalik Buterin, and he was really into Bitcoin first. So he had a really thorough understanding of the Bitcoin technology before he came up with Ethereum. It includes a distributed virtual machine, which is Turing complete, and that is interesting because for the smart contracts. And he just copied the schema, and he was open source, which basically created the situation that you can no longer create or even think about creating a blockchain technology without having that open source. So it's not optional to be an open source domain, it's actually mandatory. So if you compare Ethereum and Bitcoin so far, common traits is a virtual currency, it has a peer-to-peer network, there are the concepts of addresses, transactions, mining, so I can skip that, and there's small differences, but the conceptual part is actually the same. The main difference is Ethereum is specification driven, so there's a specification for the Ethereum client, which leads to a number of competing implementation. Whereas in Bitcoin, there's a Bitcoin core reference implementation. You sometimes have a hard time to create something that could compete with that. And the next difference is smart contracts. and including the Ethereum virtual machine and the concept of gas, which is kind of special. So this is the reason why we go to look at gas. What is this? Basically, it's a unit to pay the mining nodes. Basically, the unit that you pay the nodes, which is the incentive that they're actually running the nodes. Unit of gas has a price in ethers. So basically, you pay some ethers, you get a number of gas, and with that, you can do stuff. What can you do? You can pay transaction fees, but you also can pay for the execution of smart contracts. Basically, you pay for the computations that are performed on the Ethereum virtual machine on the clients. The trick is that the Ethereum virtual machine is working as long as there is gas. So if you provide gas to the EVM and say, do this, it will happily start. And if you gave enough, then it will complete. If you don't give enough, it does not complete. For example, to compute a hash that is fixed, it costs 30 gas. And this is a termination thing, which is kind of a cool concept. It makes sure that the virtual machine always terminates, whatever the programmer do. So basically, if you're dumb enough to create an endless loop, or if you don't really do good software, it means that if you trigger on, you provide gas, the EVM is running, and at some point there's no more gas, so the EVM just aborts. This means your transaction did not complete, but you got rid of your money. This is a good incentive to write good code and compact code. Okay, smart contracts. What is that? Basically, it's a code written in a high-level language usually. These days, it's mostly Solidity. That code is then compiled into a bytecode which can be run on the Ethereum virtual machine. It has an owner, the smart contract. It has an address. When deployed, each smart contract has an address. And having an address, we're again at the point where an address can hold money. So basically, it can hold currency. Basically, this means that the contract itself, distributed to the blockchain, is the owner of the money. So even if you deploy money there, it does not mean that you can access that money. It's only the contract that can really access that money. Of course, you can write code that if you trigger the code, it gives money back to you. Example 2, one is flight delay insurance, and the second one is a truly autonomous car. Flight delay app, which is now live because there's some conference going on in Cancun, so they've actually managed to do also the regulatory part. So this is a fully licensed thing that you can enter your name, flight details, stuff, and then you can say, I want to insure my flight. For example, you move here 35 or 25 euros, and there's some payout scheme. If your flight is delayed by 30 minutes, you get 82 euros back. How does it work? It takes advantage of another web page, which is called flightstats.com. This is real-time information for all the flights going on, if they land, when they're supposed to land. By looking at historic data, you can calculate how likely it is that a specific flight is going to be late. This helps you for risk modeling. And based on that data, that condition here is captured in the smart contract. And by accessing at the right moment, the smart contract can pay out you without human intervention. Just looks to this thing. Usually smart contracts cannot look outside of itself, so how the link is done is a piece of code that is called an oraclize library. What it does is basically, it allows you to access information through specific pages. It makes sure that if you rely on that information, nobody did tamper with that information, which makes it's not complete trust in the blockchain, it outsources a part, but it's mostly good for many use cases. Basically, you could attack that smart contract only by hacking flight stats services. Either by denial of services or by completely hacking what they do, then you can make sure that you get more money than everything else. But I think this combination between oraclize and Ethereum, this will become pretty big. So next example, truly autonomous cars. You have been getting used to autonomous cars. You drive around, you don't need to drive. But there's a nice combination in Germany this year. The RWE, they introduced charging stations which are connected to the blockchain. Basically, to pay for your currency, you can move ethers over there and you get the right to load your battery. This means that you can add a smart contract for the car, and you can do other things. So basically, if you order that autonomous car, you move some funds to the car contract, and you say where you are. This triggers the car to come to your place and pick you up, so the car can accumulate funds. With these funds, the car can do stuff. The car can pay for energy over here. It could also make a competition to be cleaned. So it can be cleaned, for example, by you. If you're the lowest bidder, the car will come to you and you clean the car. Something like that. Okay, from these high-level examples, let's go to Hello World. First, we do the greeter with the Web3 JavaScript library, and it works like that. We have seen this example here in Bitcoin case. In the Ethereum case, we have not a Bitcoin client, but the Ethereum client. And we have seen that there's a specification. The typical client most people are using is the Guess client, which is written in Go, but there's also a JavaScript client, which is called TestRPC. Why TestRPC? Because this simulates the blockchain in memory, which is really useful if you want to write unit tests against that stuff. And it has an interface, which is a JSON RPC interface available under this port. And there's a JavaScript library called Web3 that we're going to see in a minute. And there's also a Web3J library, which you can use when you're in the Java space. So basically, in the Hello World, this is Solidity code. It's as a contract greeter. The contract has an owner that we want to remember. There's a string for if you create a new contract, you run through this constructor. You say you want to provide this greeting. And the first thing it does, it's remembering who is triggering this transaction. And with each transaction, you know who the sender of that transaction was. So here you can remember who the owner was. This is important. We'll see this in a minute. And there's a main function, greet. It just returns what we provided when we created the contract. And there's a function kill. And with kill, you can basically kill the smart contract. This is a means of cleaning up after yourself, so you don't congest the blockchain with stuff that is long obsolete. We have heard before that the contract can hold money, and you cannot access the money. So how do you get the money? Assuming that you want to kill your contract and you want the money back, you have to implement this kill function. If you don't implement, then the money is just stuck. So you have to do that. But anybody can call that kill method. So you want to make sure that if you're the owner of the contract, only you can have the possibility to kill and get the funds, which is basically this. If the sender is the owner that you registered here in the constructor, then you run self-construct, and in that case, the contract itself is moving all the funds that it has to the owner address of the contract. As long as you don't do this, you cannot directly access that money. Small extension. There's just an integer for number of deposits, and the default function, which has the keyword payable. If you want to move money to a contract, you need to have at least one function with this payable, and only by calling this function you can start to move funds to that contract. And that's just basically accessing the number of deposits and so on. Once you have this piece of source code, you need a Solidity compiler. One is online available, which is pretty neat. You copy-paste the source code over here, it compiles, and you get out the bytecode over here. You also get some interface string, which you also need, and it shows you a thing where you can actually deploy with the Web3 JavaScript library to the blockchain. And this is all I said, deploy script. So if you're in a shell and you have the Web3 JavaScript library loaded, you can use that script to basically deploy the contract and to do stuff. If you successfully deploy, you'll get back the contract address, so you know where in the blockchain your contract is living. And by calling greet, you see hello world, so success, that did work. So let's move to the Java space and do basically the same. We have seen that there's this RCP JSON interface, and a guy decided to do this for Java as well, not only JavaScript. This is the homepage of that thing. And if you have initially the binary code and the API, basically this interface string, you can use a command line tool to create or to generate the greeter Java, which you can then just use to work with that library. Let's look at this in real life. In the demo. So basically this is a small contract demo. There's an address called Alice, so we move some funds to Alice, then we can deploy the contract, so Alice is then the owner of that contract, and using that contract, there's a method that moves some money over there, we call greet, and we kill the contract. I can run this as just a normal Java application. And it's like biff, and it did all that stuff. And it's so quick because it did run against TestRPC. If you would run this against the live chain of Ethereum, this would take a minute or two. So it's really cool you can really do JUnit tests by shooting against this TestRPC library. So let's do a slightly more extensive demo, which is a trading network demo. The use case is currency hedging. You want to manage buy and sell orders for Euro against US. Basically, it's a classical business application. Why do we need a business application? Well, whatever, if you have startups or whatever, you usually need to do some identity management. We see now that more and more of these startups, even in the blockchain space, they realize that they have to take seriously things like money laundering, so they have to do AML and they have to know your customer, so they're slowly adding. Even before the regulation is completely here, they start to add this stuff because they get afraid if they don't do, they will be shut down too early. It also includes a Web3J library and Eclipse Scout to build basically the application around it. So the benefits of using the blockchain is efficiency. Efficiency in the sense that if you do this hedging game, usually there are many organizations involved which do not necessarily trust each other. If you do this with classical infrastructure, you're usually forced to set up an independent organization where the participating organization, they trust that they don't mess up. And the trick with blockchain is that you can delete the independent organization you don't need. So you don't need housing, you don't need employees, you don't need almost nothing. You just use, for the trust part, you can use the blockchain. Because blockchain is offering you a tampering-proof ledger, so basically offers you the whole trust business. And this is also why the financial industry starts to get nervous, because they're really in the trust business. And now there comes a technology which promises to solve the trust thing. So how is the demo organized? There are two Docker containers. One is holding the Ethereum client, the TestRPC, is the Web3 interface, and the other one is a PostgreSQL database. Then there's a backend server with Scout, which is using, as we see before, the Web3J library, JDBC to access database, and some UI layer. I try to demo this. So let's start to first here. If I write Docker PS. We can see that this is my database container and this is my container holding the whole TestRPC installation. So I don't need to install stuff, I just can run this Docker image. And in one thing, here I'm logged in as the Munich Re company, and in the other browser I'm BMW. BMW has some sell deals and Munich Re has some buy deals. You don't see the buy deals because they're still here local. It says local unpublished, so these guys are in the database. I can then say I want these guys to be published. They're pending, so they have to wait until they're really confirmed in this Docker container. If I go here, I see now the overview over all the things, and if I refresh, I can also here see the overview. So what do we have? It's kind of, this is the order book. We see that this is kind of sorted, where in the middle it tries to be as close as possible. This means that BMW would like, for 200,000 for this exchange rate, try to sell, and Munich Re would buy, but not for so much, but slightly less, 500,000. So there's no match, no nothing, but you then can see if the, I have to go, if I'm Munich Re, let's switch here, and I want to have a deal, I have to basically create a new deal, a new buy deal, and let's say I want to have 100,000, and here I can get the current exchange rate. Basically, it's just looking in the order book at which range I have to put here in order to make sure that there is a deal. Now, if I switch back here and refresh, of course I cannot see anything, because again I have to publish this guy first. And now the software identifies here that there is a match here for this deal with this deal. If I execute it, then this part of the deal will be fully executed because I can buy 100,000, and this cannot be fully executed, then this number goes down to 100,000. So I can execute buy order, and again I have no match here. So that's the kind of the demo. I don't know if I time. Yeah, well, I'm running out of time for the demo. Maybe I can show one thing. If I'm here, then I can also switch to the Docker container and use the test3, the Web3 JavaScript in order to verify what I see in the UI that is actually on the blockchain, which is pretty easy to do. So if you want to learn more about smart contracts in Ethereum, there's the homepage, there's a white paper of Ethereum, there's some good documentation about the Web3 JavaScript library, there's also Eclipse Scout. So we come to the summary. Blockchain, Internet of Trust. Yeah, that's my time. It's a cool new technology, lots of hype as well, but technology is cool. It's a technology for unbanked, and unbanked are on the one hand people they're not allowed to have accounts, but unbanked are also machines. So it's also a solution to give the authority to accumulate and spend funds to machines, which probably has some potential. It's an efficient, trustless global exchange of values. If you have an open and a public network, you could also do private networks, but that's a different topic. And it really is pushing distributed business models. Challenges currently are privacy, as Bitcoin and Ethereum, they don't have private transactions, so everybody sees all the transactions. One, the connection between an address and the person gets leaked. You can go through the full historic database and maybe find out a lot of things with network analysis. This is not always wanted. So many of the blockchains now, they try to find new ways to address privacy in a sense that you can no longer see where the money is coming from, but still have the trust that nobody is funneling the funds into wrong directions. Another topic is scalability. In order to be used for mass transactions, if you really want to, everybody wants to pay coffee with cryptocurrencies, 7 transactions per second will not do. This is also addressed by various currencies. It's in development if you want. Another one is energy consumption. Bitcoin network these days is using as much energy as the country of Ecuador just to be run. So this is the proof of work, the hashing stuff, which is really insane if you think. There's another approach which is probably coming shortly to the Ethereum network, which is moving from this proof of work algorithm to proof of stake algorithm. So this means instead of calculating hashes, there's a setup where you say, for the mining, I put some money on the side and this is locked, which gives me the right to do mining. Basically, I promise not to mess up with mining, which is then not calculated, but more on a trust basis. If somebody can show that I mess up with mining, they will kill my funds. So I, as a miner, have an incentive to be trustworthy in order not to kill my funds. This is the gist of the proof of stake. And this would then basically solve a huge part of this energy consumption. Another one is maturity. Even though there's a lot of money in it, blockchain is really still in its infancy. So there's a lot of topics that are not fully addressed, that it's not really clear what will happen. So it's really early stage. And regulatory, well, let's say it's a mess. Everybody has a different idea about it, which heavily collides with the fact that it's really simple to set up a global network, which does not care about somebody telling what you can do and what you cannot do. So they'll also have to solve this one. Okay, thanks. You have questions? No? Okay.